Good day everyone. In this video, we are diving deep into the world of SQL Server to uncover a fascinating phenomenon, last page insert contention. If you're a database enthusiast or a curious tech lover, this one's for you. We'll be exploring a common challenge that SQL Server developers and DBAs often encounter, the infamous last page insert contention. But fear not, because we are going to tackle it head on and discover some exciting solutions together. But before we delve into the technical nitty-gritty, let's quickly understand what last page insert contention is all about. Imagine a SQL Server table where rows are continuously being inserted at a rapid pace. The last page of that table becomes the battleground where all those insert operations compete for access. This intense competition can lead to performance bottlenecks and slow down your database operations. Don't worry, we have got you covered. In this video, we will simulate a real-life scenario and witness turmoil firsthand. We will fire up multiple SQL sessions, each vying to insert data into the same table concurrently. We will then analyze the impact on performance and observe the dreaded page latch underscore ex wait type in action. You will see how SQL Server 2016 handles this contention, and we will explore some effective tips and tricks to conquer the last page insert challenge. Whether you are a seasoned SQL guru or just starting your database journey, there is something valuable for everyone. So buckle up and get ready for a thrilling ride into the world of SQL Server last page insert contention. Let's get started. Let's create the required objects for performing this last page insert contention demo. I'm going to create a table called table 1. Table 1 has got 3 columns. Column 1, which is a primary key. It is an integer and has a value of identity 1, 1. Column 2 is varchar 100 and column 3 is integer. I'm going to create an stored procedure called USP underscore insert data. So what it basically does is like it basically inserts some random values to table 1, and for each execution it will be inserting close to 1000 rows. Let's execute it. So now what I'm going to do is like, now that we know that this table 1 has got column 1, so every insert basically happens kind of like that series of insert will basically use the same page to insert the data, because what will happen is like the value with the primary key, it will be incrementing by 1. That is, whatever is the previous row, it is going to increment it by 1, and the next row will have that value. So what will happen is like it will all be using the same page. It is not that all the rows are going to use the same page. It is basically like that series of whatever insert that we are going to perform that is going to use the same page, and then when it spills over to another page, all the inserts that is going to happen after that will be using that particular page. So that means like there will be, when you are executing several sessions and executing this stored procedure, there is high possibility that all these sessions will be trying to hold that particular page to get the information and perform an insert. So at that point in time, we will have a latch contention. So let's look at it. So what I'm going to do now is like I'm on SQL Server instance called JBS Wiki, and the instance name is JBS. So what I'm going to do, I'm going to perform an execution of this stored procedure continuously. Okay, and if you look at it, I'm using a tool called SQL Test from SQLworkshops.com. So here what I'm doing is like I have 4 workloads: workload 1, workload 2, workload 3, and workload 4. And what I'm basically doing is like I'm inserting, I'm basically executing this particular stored procedure on all the 4 workloads, which basically inserts 1000 rows for every execution. And what I'm basically asking this tool to do is like to execute this 4 workloads for 300 seconds, which is 5 minutes. And then the number of threads used by each workload would be 100. So what I'm going to do is that I'm going to start this, and then let's see what happens. Okay, so SQL log scout is also executing in the background just to capture what is going on. So now what I'm going to do is like I'm going to click on start all, and I'm just waiting for it to show something here. So if you see here, the 4 workloads are started now, 1, 2, 3, and 4. And here we will be able to see what is going to be the iterations, how many iterations are done, and also the average DB time per second. So right now, what I'm seeing is like it is taking close to 16 seconds. Yeah, it is 17 seconds, 18 seconds. So right now it is on close to 20. It is increasing. The iterations of is close to 100, and then what I'm seeing is like the average DB time, that is this query average execution is taking close to 22 seconds. Yeah, so you can change this to milliseconds, but I will leave it to seconds here. So right now we are seeing it as 22 seconds. Yeah, now what I'm going to do, I'm going to run this sp underscore who is active. And then if you see here, what I'm seeing is like we are seeing a lot of queries basically waiting on page latch underscore sh, page latch underscore ex. And I think it's like each and every session is like waiting like close to 100 milliseconds, 165 milliseconds. Now it is 24 milliseconds. So it is like just this page latch wait itself is like more than 100 to 200 milliseconds. That is what I'm seeing. So now what I'm going to do is like I'm going to look for the wait statistics. Yeah. So what I'll do is like I will open the wait statistics file here. So let me clear this. I know like it has started before like 3 or 4 months, but I will clear the wait statistics and then I will execute it one more time. Now, if you see here, what I'm seeing is like the page latch EX is basically topping the chart here, and 48% of the wait statistics is on page latch underscore EH, and 24% is on page latch SH. So basically it is like close to like 72% is basically page latch underscore sh, wherein the latch is being taken on the memory and the contention is basically happening while accessing that page. Yep, so that is what we are seeing here. So let me execute it here. So we are seeing here, it is consistently increasing. The page latch underscore ex is like increasing consistently, and the wait time is like the wait time percent is like close to 45%. Then now the second one in the list is write log, because we know we are doing a lot of inserts. So the work on the transaction log seems to be a little high, but what I'm seeing is like page latch is really high. Let's execute one more time. So what I'm seeing is like 45% is page latch underscore ex. Yeah. So we are able to clearly see that page latch is definitely increasing. And let's look at the average DB time seconds. It is basically 23 seconds. Now it has increased from 21 to 23 seconds. So we are able to see like this insert that is happening, which is basically getting inserted using this stored procedure USP underscore insert data. What I'm able to see is like this is basically each execution on average is taking close to 23 seconds. Yeah. So in real world, if we don't have the latch contention, then it should be completing quickly. But right now, since we have this contention, what is happening is like the insert performance have really deteriorated. And also like let's go back to the SSMS and then let's execute this sp underscore who is active. And what we are able to see is like there are some blockings also going on. So if you see here 340, this one is blocked. There are 340 SPID is blocking so many other SPIDs. Yeah, so we know that it is all the same insert statement, same stored procedure, but we have good amount of blockings here. Yeah, So two problems here. One is like the insert performance is very bad, and that insert performance is very bad because of page latch contention and also like due to blocking. So now if I'm able to see here, we have some serious blocking issues like 355 SPID is basically blocking all other sessions. That is what I'm seeing here. It's severe blocking here. 429 is blocking. So these are the two things that we are facing right now. So if we see here, it is going to end now. So now what I'll do is like I will stop the PSS diag as well. And now once the data is collected, what I'll do is like I will basically load this data into SQL Nexus, and then I will load that again in the Power BI report, and then I will resume this video again for discussion. Okay, so I've loaded the SQL log scout data into SQL Nexus. I'm going to look at the information here. So first I will look at the best practice and analysis summary. So the first one, it basically tells like we have expensive X events, maximum memory warning, and then max degree of parallelism is also set to 0. But I'm just checking whether we have anything related to page latch contention. We don't see anything here. So let me go back. And then now what I'll do is like I will look at blocking and waiting statistics. So if I see here, what I'm able to see is like page latch contention, that is page latch related weight seems to be at the top of the chart. Yeah, so those are like really, really high. And then next comes write log. So what we understand is like from the captured log scout data, it is pretty clear like page latch comes first and then comes write log. So now if I look at the details here, what I'm able to see is like there are so many queries that are waiting on page latch waits. It's not page IO latch, so don't get confused with that. It is a non-IO wait. Page latch waits are basically due to like if you have consistent page latch waits with good wait time, then it is basically points to a latch contention on the database server. Yeah, so we are able to see like there are a huge page latch waits on the database server when we took this data collection. Yep. Now what I'll do is like I will switch to the Power BI reports that is part of your SQL Nexus. And here, if I look at it here, this also shows like page latch related weights. Either it is page latch EX or page latch SH. It is close to 72%. So let's go to the weights and latches here. And then if you see here, 73% is page latch and 26% is write log. So that's what we are seeing. And if I look at the CPU utilization here, what I'm able to see is like it is close to 50%. Yeah. So if I look at it here, it shows me like SQL utilization is close to like 50%. Yeah, it is showing us 37% here. So it's not a high CPU utilization condition. It is just like we are able to see 37%. But if you look at the workload, what we are able to see is like we completed close to 1,230 iterations in 5 minutes. And the average time for this stored procedure execution is close to 23 seconds. That is what we are seeing. Yep. Now what I'll do is like I will go into the SSMS and then check certain queries from the SQL Nexus and see what we see there. Yep. And now if you look at this one here, what you're able to see is like 39% is like page latch. So definitely we are spending good amount of time in this page latch underscore ex wait. Yep. Now what I'm going to do, I'm going to execute some queries, TSQL queries on the SQL Nexus database, and then check what informations we have there. And also like I'm taking these queries from one of the website. I'm going to put that in the description as well. Yep. So if we look at it here, let's look at the other query. Uh, to, okay, so first one is like, let's look at what kind of blockings we have. Yep, let's first look at if we have any blockings, and if we have blockings, let's look at the head blocker and things like that. Let's switch over to the SQL Nexus database and then execute this query. So definitely we are able to see blockings happening on the database server. So if I look at it here, so the start time and end time is like, basically we are checking the blocking details between 4 p.m. to 4:05 p.m. And what I'm able to see is like for each of these entries here, we are able to see good amount of blocking here. Now let's look at the head blocker. So head blocker, if we look at it here, what I'm able to see is like, this is the head blocker and this is the blocked sessions. Yep. And what we can clearly see is like the head blocker as well as the blocked sessions, everything is waiting on page latch. Okay. And if you look at what queries are involved in the blocking, let's go in here, and what we can see is that the head blocker is USP insert data, and this is the insert statement that is the head blocker. Okay, and then if I look at the blocked sessions, what I'm able to see is like it is again the insert statement, but let's look at the actual data here. So it is all page latch waiting on, and if you look at it, the blocked sessions are also executing USP underscore insert data stored procedure and the same insert statement. So the head blocker, the block sessions are all same stored procedure and same statement that is getting executed. What is odd here is like all these queries are waiting on the wait type of page latch underscore ex. That's same for all the occurrences. So for example, if I go there, random, I'm able to see that it is the same behavior that is happening on the database server. So the blocking session and the block sessions, the head blocker, the blocked sessions, both are executing the same insert statement that is coming from the same stored procedure. So now what I'm going to do is like, I'm going to look at this particular query and then see exactly what other information that I can get. Okay. Let's look at the top 5 resource consuming queries. I'm going to query the SQL Nexus database. And then if we are able to see here, what I'm able to see is like USP underscore insert data stored procedure seems to be the costliest query here. But what is strange here is like, if you look at compare this duration and CPU utilization, what I'm able to see is like the duration seems to be very, very high, but the CPU utilization for this query is comparably less. So which basically tells us like the query actually executed for less amount of time, but the duration, that is the time it took to complete the query, is very, very high. And this usually tells us like there is a waiting condition. Yeah, so that is what we are able to understand. So now what I'm going to do is like, I'm going to look at the whole data on the SQL Nexus database, and I'm going to group wait type, proc name, and statement underscore txt, and then I'm going to see like which query was waiting more on any particular wait type. I'm going to check that. So let's execute this query, and what I'm able to see is like this USP underscore insert data, it waited like 6,509 times. So it is close to like 11,300 times it basically waited on page latch. Yeah. And then 90 times in latch underscore sh. And also if you look at the wait duration in millisecond, the page latch wait seems to be very, very high. And also let me go to the retrace report, Power BI report. And if I look at it here, what I'm able to see is like this particular query, USP insert data, that's tops the list of costly queries. And what I'm able to see is like it was utilizing close to 99.3% of CPU, 99% of reads, 82.6% of overall writes, and then duration is like completely the queries that were running on the database server, this seems to be very, very costly. And again, if I look at this data, what I'm able to see is like, let's execute this query one more time. And what we are able to see is like the duration is very, very high, and CPU utilization is comparably less, which basically tells us like we are waiting on something. And this query clearly tells us like this query is 99% waiting on like page latch underscore sh. So it's a clear clear case where this query is waiting on last page insert contention. So what we'll do now is like there are so many solutions for this. Right now we are on 2016. What we'll do is like we will try executing the same test on SQL Server 2022 also, and then see like how many iterations were completed within 300 seconds, that is 5 minutes, and also see what would be the average DB time in SQL 2022. And then once that is done, we will try implementing whatever solutions possible on this particular thing. And then at last, what we'll do is like we will compare on all the solution and see which one is best for this particular condition, for this particular case, and then we will take it from there. That's it for this video. Thanks for watching. Have a great day. Jai Hind.